Okay, the famous number 12, the separable part. Here's the general rules for integrating these rational functions. If it's top heavy, like this, higher degree on the top, unless you can simplify it, we're probably, and the things you're looking for, it's top heavy, and the denominator can be factored into a product of linear functions, x minus 2, x plus 2, and they're non-repeating. If it's top heavy and you can factor the denominator into non-repeating linear functions, this is probably going to be a partial fractions decomposition problem, but after long division. So we have to long divide to get it in the right form, because we're only going to do partial fraction decomposition when the numerator is a constant for the most part. I don't think we're going to run in any other instance otherwise. So to play on, what we're looking at is, yep, there's the factorable denominator. The numerator is a mess, so we're not going to use that. So we're going to long divide. And I tried to factor too. By the way, maybe you can factor. It's worth a shot. So these are some things that go through my mind when I see this kind of thing. Could you factor the top? Maybe it'll cancel with the x. Maybe it's like x plus 2 times something to the third. If that were the case, that would help our case. But I don't have that. It just doesn't factor. So just trying to check all my bases. So then I said, all right, let's long divide this thing and get it down to something simpler. And I noticed you guys are long dividing champs. So yeah, 5x squared, multiply through, change the sign, add down, goes in 17 times, multiply through, and voila, add down, and there's 78. So remember how you write this. It's that quotient, 5x squared plus 17 plus remainder over divisor. And therein lies the rational function, 78 over x squared minus 4, that has a constant on top and factorable with linear factor denominator. And that's ready for the decomposition. The one that you did so beautifully. And then we should probably talk about what you got as an answer. It was pretty cool. All right, so that first part is done. I just integrated the 5x squared plus 17. That's done. Like, we don't have to deal with that. That's part of the integral. So for many of you, that's actually the part that's missing from your answer. Now, the last part of it, when some of you guys did partial fraction decomposition from the start, what goes on the right-hand side right after the 17x is what you got. And that is miraculous. I didn't know that was going to happen, so we need to prove why that's the case. We'll do that later. But this is the integral we're going to decompose. That's the one. I went ahead and took the 78 out. You could leave it in, set it all equal to 78, but I like to take it out. And then we can do that cross product thing and set the numerators equal. So we're going to do a times the x plus 2 denominator, b times the x minus 2 denominator. Just looking at those diagonals there. And we'll set that equal to the 1 in that numerator. We're just decomposing, we're not integrating yet, just decomposing. And choosing x's that will cancel one of the variables. So those are zeros. So think of the x's that I chose are zeros of my denominator. That plays into this, something I'll talk about later, but we're choosing zeros, things to zero out those denominators. And then solving for b, because x equals negative 2 cancels the a. Then x equals 2 cancels the b. We get a is 1/4. Cool so far? I'm going to peek at that. That's the stuff we're going to integrate. Don't forget it's going to have the 78 out front, and I didn't indicate that well up above. I was kind of left that off. Should be a 78 in there. Should I make it big? 78. 78. Goes right there. Continuing on. So this is what I got. 5/3 x plus 17x is what I had before. And then I'm going to go ahead and do the antiderivative of, if I go back up, what I'm leaving off here, and I should probably put that back in here, is this integral of 78, oopsie, and then our 1/4 on top of the x minus 2, and our negative 1/4. So I made it minus 1/4 x plus 2. And sorry that overlapped, but that's what I'm integrating. And that result of that little blob right there with the dx is over here. So I put my a and b in there, integrated it. The 78's just hanging out front. Those are logs. Those are both linear functions. So it's integral of 1 over u is natural log of absolute value of u. So continuing on, you bring me back anything that bothers you. And then if you take 78 times a fourth, there's your 19.5. Now notice the 4 or 5 of you that did it, you only had the stuff on the right. It was missing the front part. And that's kind of weird, I thought. I thought you all were just forgetting to write down the first part. I didn't realize you're all doing your separation, your integration by partial fractions. Just left something off. Cool. That's the story on that one.